Many networking experts, myself included, often overestimate their level of understanding. They believe they have full control over their networks after years of studying, learning, and gaining expertise in the field. They can design and implement large networks and provide effective solutions for managing and operating them. However, in reality, they are simply skilled operators of network devices. This is because they lack in-depth control over how these devices communicate with each other. Communication between devices, my friend, is governed by their control planes, which ultimately determine how data flows through the network. This situation is akin to expert drivers who understand how to operate a car in various situations through learning and practice. Yet they are still just skilled car operators. This narrative has persisted for decades, from the early day of networking until recent years. However, with the emergence of SDN, this narrative has begun to change. It's quite intriguing. So, if you are curious to learn more, stick around till the end. Hello everyone and welcome. I'm Farhad Ali Karami and I'll be your guide on this exciting adventure into the world of software-defined networking, or SDN for short. In this video, we are going to explore the key points in the world of SDN that will help you gain a valuable understanding of it and find your way to become a real network expert and get in-depth control of your network to make everything happen for your business. But before we delve into the technical details, don't forget to hit that subscribe button and ring the notification bell. This way, you'll stay updated on all our future tech talks. So, if you are as excited as I am, let's get started. SDN, or software-defined networking, is a way of setting up networks by separating the control part from the data part. Normally, in devices like routers and switches, both control and data moving are closely connected. But with SDN, these jobs are split up, making it possible to control everything from one central place and to program it as needed. Now, you may ask, what are the control plane and data plane? Let me briefly explain. Imagine you are at a traffic intersection. In the traditional networking, it's like the traffic lights and the flow of cars are all managed in one place. But with SDN, it's different. Picture the traffic lights being controlled from a central headquarters, sort of like a command center. From there, they are able to manage the flow of cars at different intersections, almost like magic, using the latest information and following specific rules. In this example, traffic lights represent the control plane and the flow of cars represent the data plane, okay? If we compare it to a networking example, the control plane is where protocols like routing protocols, spanning tree, and so on negotiate with each other to make decisions on how and where data should be forwarded. On the other hand, the data plane simply obeys the decisions made by the control plane. It carries the data from the source to the destination. Great. But you might be wondering, okay, so SDN separates the control plane from the data plane. What's the significance? Let me explain. By splitting these two parts, my friends, SDN essentially divides your network into two main sections, the overlay and the underlay. Think of it like a building with a strong foundation, the underlay, and a versatile, customizable space on top, the overlay. This division allows for more flexibility and creativity when designing your network to meet your specific needs, okay? SDN differs from traditional networking because it provides dynamic and programmable control over network resources. Unlike fixed setups in traditional networks, SDN allows for automation, agility, and adaptability to changing demands by separating the control plane and data plane. In simple terms, in the world of SDN, software manages the control plane, directing it to meet your requirements, while you can focus on ensuring the reliability and stability of the underlay. Sounds good, right? Essentially, SDN empowers networks to be more flexible, responsive, and efficient, making it a fundamental aspect of modern networking architectures. Now, you might be wondering, what exactly is SDN? Is it something you can buy for your network? Is it a specific software or license that performs these cool tasks? To put it simply, no. SDN is not a tangible product, software, or license. It's actually an approach that allows a specific software acting on your behalf to design and manage networks. Okay? These software, known as controllers, can be developed by you, established vendors like Cisco and VMware, or they can be open source or even a combination of these, depending on your business needs. The key thing to understand, my friend, is that SDN is an approach that utilizes a specific software as well as AI and ML technologies in the background to address the increasingly complex demands of modern networks. If you're curious about how SDN came to be, let me give you a quick overview. SDN emerged as response to the limitations of traditional networking setups. This started with research in the mid-2000s focusing on making networks more flexible and easier to control. Here are some important milestones in the evolution of SDN. 2008, Stanford University introduced the concept of SDN with the OpenFlow protocol. This allowed for centralized control over network switches. 2011, the Open Networking Foundation, or ONF for short, was formed, aiming to standardize SDN and encourage collaboration within the industry. 2013, major networking companies began embracing SDN, offering products and solutions based on these new standards. 2015, SDN started gaining popularity in business networks, thanks to its ability to automate tasks and quickly adapt to changes. 2020s, SDN continues to evolve to tackle new challenges in areas like cloud computing, edge computing, and 5G networks. It became an essential part of modern network setups. Today, SDN plays a crucial role in networking, providing centralized management and control of network resources, quick and flexible setup of services to meet changing needs, improve security and policy enforcement through programmable controls. My friends, in a world where technology is advancing rapidly, SDN is leading the way, making networks more efficient, scalable, and adaptable. Now that you're familiar with what SDN is exactly, let's explore its use cases specifically in 2024. SDN is revolutionizing networking across diverse industries, including finance, healthcare, education, and telecommunications. From optimizing data centers operations to enhance network security, SDN is deriving innovation and efficiency. In data centers, my friends, SDN plays a crucial role in automating and optimizing network operations. By centralizing control and dynamically allocating resources, SDN reduces manual configuration tasks, improves resource utilization, and accelerates service delivery. SDN is the backbone of cloud computing, enabling service providers to deliver scalable and flexible infrastructure as a service IaaS solutions. With SDN, my friends, organizations can dynamically provision and manage virtual network resources, ensuring optimal performance and cost efficiency in cloud environments. With the advent of 5G networks, SDN facilitated the implementation of network slicing, a key technology that enables the creation of virtualized network slices tailored to specific applications or services. Whether it's ultra-reliable low-latency communications or URLLC for mission-critical applications or enhanced mobile broadband EMBB for highest-speed internet access, SDN enables network operators to efficiently manage and optimize resources to meet diverse service requirements. In essence, SDN is empowering organizations to build agile, scalable, and resilient networks that can adapt to the dynamic demands of modern digital ecosystems. Okay, great. We saw what are SDN use cases briefly in 2024. Now, let's look at opportunities created with SDN. SDN presents exciting opportunities for businesses to enhance their network infrastructure and operations. By embracing SDN, my friends, organizations can unlock new possibilities for innovation, efficiency, and competitiveness in today's digital landscape. One of the key benefits of SDN is its ability to streamline network management processes. By centralizing control and automation, SDN simplifies network provisioning, configuration, and troubleshooting, leading to significant time and cost saving for IT teams. Great. SDN helps businesses reduce operational costs by optimizing resource utilization and minimizing manual intervention. With SDN-enabled automation and orchestration, organizations can achieve greater efficiency in resource allocation, resulting in lower capital and operational expenses. My friends, SDN offers unparalleled scalability and flexibility, allowing organizations to adapt to changing network requirements with ease. Whether it's scaling up to accommodate increased traffic or deploying new services rapidly, SDN empowers businesses to respond swiftly to evolving demands without overhauling their entire network infrastructure. Great. Finally, SDN opens the door to innovation and new service offerings by enabling programmable control and dynamic resource allocation. SDN allows businesses to deliver customized services tailored to their customers' needs. Whether it's providing virtualized network functions or offering innovative network solutions, SDN unleashes creativity and derive business growth. In summary, my friends, SDN presents a wealth of opportunities for businesses and organizations to optimize their network operations, reduce costs, and derive innovation in 2024 and beyond. Okay, well, after exploring SDN and its application, I know you agreed it is awesome. But just like any other technologies, implementing it has its own challenges and considerations. Let's look at them briefly. Implementing SDN can be complex, especially for organizations transitioning from traditional network architectures. Common challenges include integration with existing infrastructure, ensuring compatibility with legacy systems, managing network migration without disruptions. On the other hand, security is a paramount concern in SDN deployments. Centralized control and programmable infrastructure introduce new attack vectors and vulnerabilities. To mitigate risks, organizations must implement robust access control and authentication mechanisms, encrypt communications between SDN controllers and devices, regularly update and patch SDN components to address security vulnerabilities. My friends, SDN requires a skilled professional capable of designing, deploying, and managing SDN environments effectively. Organizations need network engineers with expertise in SDN technologies, programmers proficient in network automation and scripting languages, security specialists well-versed in SDN security best practices. Another very important challenge, my friends, is interoperability. Interoperability issues can arise when integrating SDN solutions from different vendors. To ensure seamless interoperability, industry standards play a crucial role. Organizations should prioritize solutions that adhere to open standards such as OpenFlow and NetConf. Engage with vendors and industry consortia to promote interoperability and standards compliance. Test interoperability in lab environments before deployment to identify and address compatibility issues. In summary, while SDN offers compelling benefits, organizations must address challenges related to implementation complexity, security, skills gap, and interoperability to maximize the value of SDN in their networks. Congratulations on reaching the end of our journey through software-defined networking or SDN. Let's recap the key points we've covered and encourage further exploration. Throughout this video, we have explored the fundamental concept of SDN, including the separation of the control plane and data plane. The evolution of SDN from its origins to its growing importance in modern networking architectures. Real-world application of SDN across various industries, from data center automation to 5G network slicing. The opportunities SDN presents for businesses, including streamlined network management, cost reduction, scalability, and innovation. The challenges and considerations associated with SDN implementation, such as security concerns, skill requirements, and interoperability issues. As you continue your journey with SDN, my friends, I encourage you to explore further resources, including online resources and tutorials on SDN fundamentals and advanced topics, industry publications and research papers on the latest trends and development in SDN technology, community forums and discussion groups where you can connect with fellow enthusiasts and experts in the field. Remember, your curiosity and willingness to learn are the key to mastering SDN and unlocking its full potential in your network infrastructure. I invite you to engage with us further by leaving your comments, questions, and feedback below. Let's continue the conversation and empower each other to succeed in the exciting world of software-defined networking. If you enjoyed this video, don't forget to hit the like button, subscribe for more tech talks, and ring that notification bell to stay updated. If delving into SDN world sparked your curiosity, you won't want to miss the valuable insight waiting for you in our earlier videos. Okay, well, I'm Farhad Ali Karami, and I can't wait to see you in the next video.